Schist is a medium-grade metamorphic rock with medium to large, flat, sheet-like grains in a preferred orientation. It is defined by having more than 50% platy and elongated minerals, often finely interleaved with quartz and feldspar. These lamellar minerals include micas, chlorite, talc, hornblende, graphite, and others. Quartz often occurs in drawn-out grains to such an extent that a particular form called quartz schist is produced. Schist is often garnetiferous. Schist forms at a higher temperature and has larger grains than phyllite. Geological foliation with medium to large grain flakes in a preferred sheet-like orientation is called schistosity. The names of various schists are derived from their mineral constituents. For example, schists rich in mica are called mica schists and include biotite or muscovite. Most schists are mica schists, but graphite and chlorite schists are also common. Schists are also named for their prominent or perhaps unusual mineral constituents, as in the case of garnet schist, tourmaline schist, and glaucophane schist. The individual mineral grains in schist, drawn out into flaky scales by heat and pressure, can be seen with the naked eye. Schist is characteristically foliated, meaning that the individual mineral grains split off easily into flakes or slabs. The word schist is derived ultimately from the Greek word ifloron I paragraph I micron I to the first I 1/2 shazian meaning to split, which is a reference to the ease with which schists can be split along the plane in which the platy minerals lie. Most schists are derived from clays and muds that have passed through a series of metamorphic processes involving the production of shales, slates and phyllites as intermediate steps. Certain schists are derived from fine-grained igneous rocks such as basalts and tuffs. Schists are frequently used as dimension stone, which is stone that has been selected and fabricated to specific shapes or sizes. Historical mining terminology: before the mid-18th century, the terms slate, shale and schist were not sharply differentiated by those involved with mining. In the context of underground coal mining, shale was frequently referred to as slate well into the 20th century. Formation: during metamorphism, rocks which were originally sedimentary, igneous or metamorphic are converted into schists and gneisses. If the composition of the rocks was originally similar, they may be very difficult to distinguish from one another if the metamorphism has been great. A quartz porphyry, for example, and a fine-grained feldspar-thick sandstone, may both be converted into a grey or pink mica schist. Usually, however, it is possible to distinguish between sedimentary and igneous schists and gneisses. If, for example, the whole district occupied by these rocks has traces of bedding, clastic structure, or unconformability, then it may be a sign that the original rock was sedimentary. In other cases, intrusive junctions, chilled edges, contact alteration or porphyritic structure may prove that in its original condition a metamorphic gneiss was an igneous rock. The last appeal is often to the chemistry, for there are certain rock types which occur only as sediments, while others are found only among igneous masses, and however advanced the metamorphism may be, it rarely modifies the chemical composition of the mass very greatly. Such rocks as limestones, dolomites, quartzites and aluminous shales have very definite chemical characteristics which distinguish them even when completely recrystallized. The schists are classified principally according to the minerals they consist of and on their chemical composition. For example, many metamorphic limestones, marbles, and calc schists, with crystalline dolomites, contain silicate minerals such as mica, tremolite, diopside, scapolite, quartz and feldspar. They are derived from calcareous sediments of different degrees of purity. Another group is rich in quartz, with variable amounts of white and black mica, garnet, feldspar, zoisite and hornblende. These were once sandstones and arenaceous rocks. The graphitic schists may readily be believed to represent sediments once containing coal or plant remains. There are also schistosandstones, but metamorphic beds of salt or gypsum are exceedingly uncommon. Among schists of igneous origin there are the silky calc schists, the foliated serpentines, and the white mica schists, porphyroids and banded haloflinters, which have been derived from rhyolites, quartz porphyries and felsic tuffs. The majority of mica schists, however, are altered claystones and shales, and pass into the normal sedimentary rocks through various types of phyllite and mica slates. They are among the most common metamorphic rocks. Some of them are graphitic and others calcareous. The diversity in appearance and composition is very great, but they form a well-defined group not difficult to recognize, from the abundance of black and white micas and their thin, foliated, schistose character. A subgroup is the andalusite, staurolite, kyanite and sillimanite schists, which usually make their appearance in the vicinity of gneiss granites, and have presumably been affected by contact metamorphism. Engineering considerations. In geotechnical engineering, a schistosity plane often forms a discontinuity that may have a large influence on the mechanical behavior of rock masses in, for example, tunnel, foundation, or slope construction. See also, List of rock textures, Grien's schist, pellet. References. External links, Schists. Encyclopædia Britannica 1911. An examination of mica schist by Andrea Samuels, Meckscape magazine. Photographs of Manhattan schist. 2, by USGS, Idaho, University of Idaho, Moscow, articles cited.